Hello, this is lecture 2 of the NPTEL video series. There is a reason why the term design is highlighted in this slide. Design is a significant and a broad term, and it is only appropriate for us to proceed with the CAD course after we understand the term design very well. We'll try to understand design through this lecture, while a single lecture does not justify the purpose. There are many dedicated courses and programs on design itself. The basic question: what is design? Is it art? This is a very famous painting by Leonardo da Vinci. People who know his work well consider him to be both an artist and an engineer. Was he more of an artist or less of an engineer, or vice versa, is open to speculation. Of course, the term engineer was possibly not coined then. It emanated much later. But in his time, Leonardo was able to classify or differentiate different mechanical or machine elements like the gears, links, belt and pulley arrangements, and more. Is design related to engineering, where complicated calculations are supposed to be made? Or is it rational? For example, a wheel. We all know that the wheel is one of the proud inventions of mankind and the best way for an efficient motion transfer. Do all of the above, art, engineering, or rational design, culminate into product design? While many are looking at the television set on the slide, I am looking at the cabinet, the music system, and the other paraphernalia. Of course, we see a variety of products nowadays which are so eye-pleasing. We have witnessed many in the first lecture. Maybe product design involves all. The art or engineering or rational component may be more or less depending on the product being designed. For example, a car. The engineering aspect seems more compared to the aesthetic, though the aesthetic component is very much present. Ergonomics, a person's comfort, and economics, a man's pocket, both are important as well. Our design process should involve imagination and should yield appealing and workable, rather efficient design. Appealing here has implications in terms of economics, aesthetics, and ergonomics. Economics means that the product should be affordable. Aesthetic implies that the product should be pleasing to the eye, and ergonomics means that a human should be comfortable using it. Imagination requires freedom, and constrained minds cannot think. A design process may or may not follow a set of rules. In art design, rules may be concealed. For example, the ratio of facial lineaments or features are possibly worked on before the final rendering in the form of a portrait sketch or a painting is provided. In engineering design, certain rules, for example, those related to failure, should be applied and commonly agreed upon. One cannot apply different set of failure criteria for the same design. A set of rules may or may not be common between any two design processes. A design process A may or may not be better than any other design process B. My personal opinion: the design processes may not be comparable, since many evaluation criteria based on aesthetics, ergonomics, and others are possibly subjective and cannot be quantified easily. I'm going to be delineating the design process I learned when I was an undergraduate at IIT Bombay back in 1991 to 1995. It follows about 7 stages. Stage 1 is function determination, or the rapid fire stage. Stage 2 is choosing functionality, which is based on need and affordability. Stage 3 is form rendering. This is again a rapid fire stage. Stage 4 is to choose a form. Stage 5 is developing a few chosen forms. Stage 6 is rendering spatial forms. This involves parametric solid modeling. Stage 7 is prototyping of the chosen forms or the chosen models. We will demonstrate each step through a small workshop example on the design of a table lamp in this lecture. We will work in the cooperative competitive scenario. We have about 10 students participating in the workshop. I divide them into 5 groups of 2 each. 2 students in a group will collaborate while the 5 groups will be competing. At no stage in the design process will the groups be interacting or sharing any information. As you know, we are going to be working on a mini design workshop. So first what I'll do is I'll introduce you all. This is group 1.
Pranay Sharma, Mechanical Engineering, MTech first year.
I am Abhishek Sarkar, pursuing PhD from Mechanical Engineering Department.
Pratik Jain, Mechanical Department, MTech first year.
I am Sharad Singhania, Mechanical Department, MTech first year.
3.
Myself Shweta Singh, Mechanical Engineering Department, MTech first year.
I am Vijender Pardhi, MTech student, Mechanical Department.
And this is group 4.
I am Arun, MTech first year, Mechanical Department.
And I am Ravi Shankar, Mechanical Department, MTech first year.
So let me explain you guys the basic rule for this workshop. This is going to be in the cooperative competition mode. That means that none of the groups are going to be interacting with each other for the next half an hour to 45 minutes. You're going to be keeping your design philosophies to yourself, your work to yourself. This is the design objective today. We are going to be designing a table lamp together. We are going to be following a bunch of steps. I'll tell you each step one by one. I'll explain each step, and then we are going to be working towards designing a table lamp. This is the first stage of the workshop. It's called function determination. So we are going to be following 3 or 4 basic rules. Rule number 1, try to get as many functions of the table lamp as you can. Number 2, you all know what a table lamp looks like. Okay, this is going to be a rapid fire session. So we are going to be having 3 minutes. In 3 minutes, try to get as many functions as possible for the lamp. Welcome all crazy ideas that come to you. Do not block your imagination. So in about 3 minutes, try to get at least 20 possible functions. Okay, for example, your lamp can walk, it can be on wheels, it can dance. Okay, try to entertain any crazy idea as you can. So these are the ideas from group 1.
It should have a clock, a pen stand, mobile charger, stopwatch, handle, aesthetic design,
flexible neck, night lamp, music player, global time display,
So these are the ideas from group 2.
number 1 light with multiple color, second one mobile charger, third extension slot, music system, small TV, remote control for movements, pen and pencil stand, clock, thermometer, GPS, stock update, reminder, alarm, planner and scheduler, calculator, should be foldable, internet connectivity modem, FM radio, camera, pencil sharpener, mirror, bell, cooler, bell, stopwatch, chargeable battery, and small fan.
Okay, number 1 is bulb, and number 2 is foldable wheels. Third one is watch. Fourth is music system. Fifth is alarm clock. Sixth, flower pot. Next is blinking of light in 1 hour. Next one is Next one is bell at each 1 hour. Next, calculator. Temperature indicator. Next is pen stand. Hanger. And next is remarker. Mirror. A small fan. Battery. Voice recorder. And last one is a small aquarium at bottom.
Automotive switch on and off. Movable. Movable. Fixed frame. Fixed. Adjusting high and low intensity of light. Adjusting high and low intensity of light. Rotating. Enlarging. Twisting. Self-charging. Automatic light balance. Light concentration on a single point. Light concentration on a single point. Alarm. Stopwatch. Music system with headphones. Voice sensor for on and off. Slot for mobile charger. Fixed on the wall with air pressure. Yes, completed.
Yeah, so while I will not share any information with the group members here, all I can tell you in summary is you are very much impressed with the gadgets that you see. Okay, I could see one of the groups that was still sticking to nature. Okay, more than that, I won't say anything. Now, this is the second stage. From the wish list that we have created in stage 1, all I want you to do is choose 8 plus minus 3 functions, depending on what you need and depending on what you can afford. Okay, I'll not give you an upper bound of the cost of the lamp. Okay, so you decide what the tentative cost of the lamp can be, and accordingly choose the functions from the list that you have created. Your time starts now. You may want to take about a couple minutes here, and after that I'll be asking what you have chosen and why. I'll be asking each group the same question. Take about 30-35 seconds now. So remember, in stage 1 we did not block our imagination, but now we are trying to judge each and every idea that we have jotted down. So this is what I'm going to be asking from each of the groups. What is it that you have in mind for a table lamp and why? And what would be the tentative cost of your table lamp? If I were you, I would have designed a breakdancing lamp.
Automatic self-charging, automatic light balance.
Low heat pollution production and on a single point.
You're going to be focusing your light on a single point. Okay, okay.
Like a laser.
Okay, okay, okay.
We are going to put the alarm.
Okay.
Stop watches also there.
Okay, okay.
And MIDI system with headphone, because if you're writing something so can easy. And
Is it going to be a wireless headphone or a headphone with wires?
yeah, wireless.
Wireless. Okay.
And
Did you say your cost was about 1,000 rupees? Oh, maybe you didn't mention the cost as yet. Okay, okay, okay.
and you will take the this wire, so it will be under
Okay, 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 okay.
mobile charger.
Uh-huh.
And can fit on the wall with the air pressure.
Okay.
Because it will
So you want to control the intensity of the light as and when you require. Okay, okay, okay. Good, good.
And we can also introduce a table lamp with 2 and 3 bulbs with different dimensions.
Okay, but did you have this in your functionality list before, or maybe it's a new idea that you?
Yeah, 2 and 3 bulbs.
Okay, okay,
Mean different, not together.
okay,
Different dimensions.
okay, okay, okay. Good. So this is the third stage of the design process. We call it form rendering. Okay. So what we are going to be doing here is that based on the shortened function list that you have in stage 2, you're going to be sketching different forms of your design. Okay. Again, the time that will be provided to you will be very limited. So say about, you'll have to sketch about 20 to 25 designs in, let's say, 5 minutes. Okay. So you'll have to be really fast. So my suggestion is that you at this time stick to skeletal drawings. Okay, they would convey the design intent, or they would convey the intent behind your forms. Okay, so don't work on your sketches in detail. Stick to skeletal designs. You'll have about 5 minutes, and you'll have to draw about 25. Okay, around about 25 designs of the table lamp that you have in mind. Okay, the partners can collaborate definitely. Okay, so keep your sheets ready, keep your pencils ready. Your time would start about now. So after you have sketched out about 20 to 25 forms, okay, what we require you to do in the fourth stage of this design process is to develop a few chosen forms. Okay, so what we are going to be doing is we are going to be choosing maybe 2 of the best possible forms that you have. Okay, and we are going to be asking you as to why you have chosen those forms. Okay, so this is the 5th stage of form design. Okay, so what we are going to be doing in this stage, and this is something that you are going to be doing now, you'll probably go to your host rooms and work on the 2 designs that you have chosen. Form development. Okay, so based on the 2 skeletal designs you have chosen, you'll go to your host rooms, develop your 2 forms really nicely. Okay, so keep in mind that you're going to be working with a paper pen approach. You're going to be sketching it out. Okay, you can take some expert help. Okay, you can have a sketch, a person, a friend who can do the sketching for you. Okay, develop the 2 designs really nicely. Okay, keep in mind that this is going to be a 2-dimensional rendering of your form. In the 6th stage, what I would like you to do is I would like you to choose any solid modeler of your choice and give your form a three-dimensional rendering. In other words, you're going to be designing these two forms in 3 dimensions using a computer aided solid modeler. Okay. Once you're done, you're going to be sharing the designs with all of us, and we are going to be evaluating the designs. Okay. So remember, while you're working, you are going to be working in groups, but you will not be communicating with each other with regard to your ideas or anything else. So remember, you're competing still. We have seen now how design works on paper. Now we will learn how different products or different components are designed using a computer. There are different solid modelers available commercially in the market. CATIA, Ideas, ProEngineer, AutoCAD, and many others. A few of them are also freely available on the net. The idea is not to patronize any single software in particular, but use just one as an example to show how solid modeling works. I'm going to be illustrating solid modeling through the design of two mechanical components, the spring and the bolt. First, the spring design. Using the polylines option, we draw a straight line. Then using the center edge option, we sketch the circle. We next dimension the distance between the circle and the straight line, and also the diameter of the circle. Now we modify the major diameter of the spring. Next, we revolve the circle around the axis by 360 degrees. We also take care of the fact that we translate the circle vertically by 10 units when revolving it. We get one part of the spring. We change the display to the wireframe mode, and then we use Boolean options to make copies of this part and join one part with the other. We join two different parts of the spring now. We finally have a spring. Next, the bolt design. For this, we start with the polylines option and draw an irregular hexagon. We see that the dimension of each edge is different. We modify these dimensions to get a regular hexagon. Next, we use the extrude command to generate the prismatic hexagonal head. The height of the head is 10 units. We choose one of the hexagonal planes to sketch the circle, which would be the cross section of the shank of the bolt. We sketch the circle, and in a similar way the hexagonal head was extruded. We extrude this circle as well. We extrude the circle by 100 units. We put this part away and concentrate now on modeling the threads. Thread design is very similar to the spring design. We have a vertical axis, and a triangular cross section, which is going to be revolved around the axis. We skip all the intermediate procedures and finally get the threads. We now get the main part back, position the threads appropriately over the shank, and join the threads with the shank. We have the bolt design. Although we have seen before that we can design very simple mechanical components, it's also feasible for us to design very complex structures like this one. This is a picture of Mr. Spock, one of the characters in the first generation of Star Trek. He's a Vulcan, and I'm using his picture to represent an inquisitive mind. He would ask, how do solid modelers work? What is the mathematics behind them? How do they store and retrieve information? Can they model general and complex solids at the same time? Can modeling be efficient? These are the questions that would form the gist of the rest of the course.